Now in the previous session you saw me quickly aligning the mirrors using targets and my DIY laser pointer. Now I don't want you to go away with the idea that that is the correct and proper way to align the mirrors, because it isn't. It was just a quick dirty way for me to demonstrate how easy it was to align the beam to the mirrors using this new bit of kit that I've designed. Today we're going to continue with the laser pointer and go through a full and proper calibration procedure with the machine, and also check just what its accuracy is. Now this first mirror, when you check it, might not be perfectly lined up to the center of the laser itself. If the laser beam comes out maybe 2 or 3 millimeters off center, don't get too upset by that, because what just about to follow will automatically compensate for all of that. Here's our reflection that we're looking at, and we can see that the beam, when it's at the back corner closest to mirror number 1, with this reflection it looks as though it's at about 9 o'clock and probably 1.5 rings away from the center. Now we move it to the front of the stroke and we take a look at it, and we can see that it's dropped down, which means the beam is not parallel, and it's got to come up and possibly go another ring towards the center. Let's move it towards the center to start with, and now we'll move it up. And that looks pretty good. So let's go back to the back, because we will have obviously changed the back but by nowhere near as much as the front. Now, I'm looking at this through the gap above the rear mirror, and I can see it is 1 ring away from centre and dead on 9 o'clock. So let's come back to the front again and just check what we've got. I'm looking through a gap in the back here. I would say that that's 1 ring out and at 11:45. So both the vertical and the horizontal direction, I've got the beam running absolutely spot on with this rail. Now all I've got to do is lock it up and not move it. And the most sensitive position to keep an eye on when I'm locking up is this front position, because this is going to show me the biggest error. Now it's very tricky to get to the lock nuts around the back here. Well, I would say it's still on 11:45, but I would think it's probably moved in a shade. We're 1 ring out and 11:45. We'll check it at the back again now that we've locked it up, and again we're 1 ring out at 11:45. So I'm happy that I've set that number 1 mirror. That would have been a terrible job had we had to do it with the pulsing and keep swapping bits of tape backwards and forwards. Because we've got a continuous beam here, all of a sudden it becomes very easy. I don't think we'll need our mirror anymore, and here we've got a slightly smaller target which we're going to drop into the head, and this time we're going to repeat the exercise for this x-axis. So we're going to put this right to the end of its stroke, and we will set the crosshairs vertically so that it makes more sense to read it. That we're probably 1 ring in from the outside, and as far as we can see it, it's about 7 o'clock. 1 ring in from the outside at 7 o'clock. So let's run it to this end of the stroke, and it's certainly not very easy for you to see there, but I would say that that is probably, from where I'm looking, that again is roughly 1 ring out at 9 o'clock. And then with the screws on this mirror, I've got to adjust that so that the beam comes up, and it is already about 1 ring away from centre, so I've probably only got to take it up. So as I adjust this mirror now, I should be able to make it come up. And there we go, magically it's coming up. Just like that, and I can see exactly what I'm doing, getting it onto centre, and it looks to be about 1 ring away from the centre. So with just one simple adjustment, I've now been able to get the laser beam parallel to this axis in both of these planes. Now you notice I'm not actually trying to get the laser beam to the center point on each of these targets. I'm trying to get it to the same point on each position in the target, and that's the important bit. It should be approximately towards the center of the mirror, but it can be quite a long way off center and still function perfectly okay. Now what we saw in the previous session was that if the laser beam is not lined up with the center of the lens, you get an offset in the focus point away from the center of the nozzle. Ideally, what we'd like to do is make sure that the focus point is always down the center of the nozzle. And to do that, what we shall have to do is come to this third mirror in the system, which is here, and I have an Allen key which has been modified to make it short on one side because it's very difficult to get to the screws just on the back there. But there are 3 locking screws here which you've got to undo. We'll now move down to here and we will undo the nozzle holder and drop it down so that it sits over the target. That target, the crosshair in the middle of that target, now represents the center of the lens, which should be an easy job to just steer this dot onto target center. And here we're going across one way, and then we'll come back the other way like that. And there we go. It was as simple as that. 2 movements and we've got it onto center. Now I'm going to tighten up the grub screws while I'm here. So I'm extremely happy now that I've got this machine set up perfectly. I don't have a convenient sized piece of material to hand at the moment, but what I've got is a piece of 250, something that will measure 250 for me and 500 this way. So what I've done, I've set my coordinate on the machine here to 500 and I'm going to do a pulse. And I'm now going to move it across to 0 and I'm going to do a pulse. And now I'm going to move it down. I can do 260, I think. 260. There we go. Pulse. And another one over here. .260. There we go. What I'm now going to do is measure the diagonals. And that's one of the most critical things that will tell me whether or not this machine has been set up square and true. Now the squareness is obviously determined by the actual relativity of these 2 axes, but hopefully they've set these up perfectly and I should find that I've got exactly the same dimension across these corner points. So that one is 662.5. Yeah, 663.5. So it's a millimetre out on the diagonals. And I don't think there's a lot I can do about that, because I think that that probably is to do with the squareness of the machine itself. But there is one final test that we could probably carry out to prove that. Now you can see from the reminder of the previous session how the focus point can wander around if the laser beam is not in the centre of the lens. Now this picture that I've got here shows you the red rectangle that I have just produced with its 4 pierce points at the corners. Now the black circles around each one of those corners represents a zone of uncertainty as to where the focus point might be. In other words, if I'd set my mirrors up badly, such that as the head moved across the machine, the laser beam moved across the mirror from one side of the mirror to the other, you've got this zone of uncertainty as to where the focus point or the cutting point could be. Now I've grossly exaggerated everything here to show you the sort of problem that I'm looking for. If we assume that the focus at this point was here, and then the focus at this point had moved to over here, and vice versa down at the bottom here, it was here and here, you can see now that I've produced a very out of square shape. Now that out of square shape has got nothing to do with the geometry of the machine. In other words, I can't blame the machine for this out of squareness. It's all down to the bad way in which I've set the mirrors up. So as you can see from this diagram, the pale blue diagonal is shorter than the green diagonal. And that's symptomatic of the problem that I'm seeing with my test rectangle. And that leaves me with the dilemma. Is it the machine that is out of square? Or is it the fact that my focus point is wandering around as the machine reaches each of the corners. Now there's probably one final test that I can use to prove that, and if I clamp that piece of wood in there like that and make a mark on it by twisting the nozzle and do a pulse test, and we drive it across to 500 and we do another pulse test beside it, and we do one of these down at the front corner at 260, over here at 0. Now I think one thing is very, very obvious here. Every one of those 4 positions is sitting at about 7 o'clock, close to the edge of the nozzle. So the fact that each one of those 4 corner positions is coming out of the nozzle in exactly the same position means that we've actually got the machine set up really nice and parallel with its beams. Maybe if I make one final adjustment to the last mirror, I can get that into the centre of the nozzle. I'm only putting the slightest amount of pressure on here just to mark the wood. And there we go, that's getting pretty close to the centre now. I think I'm going to leave that there. Now I don't think it's going to make the slightest difference to my squareness test, but what I will do is go back and just check that again in a slightly different position. 563 for one axis and 562 for the other axis, so we've still got a 1mm squareness problem. Obviously nothing to do with the way I've set the lacer up. It must be a squareness problem in the way the axes of the machine are set up. Well, I suppose the other thing that I really ought to check is the dimensions. It's 499.5, so it's half a mil out over 500mm, which is not bad. In the y-axis it's come out spot on at 259. For a machine this cheap, I'm moderately impressed with the accuracy. So to sum it up, it's half a millimetre short of 500 in the 500 axis, and it's spot on 300 in the y-axis, and there is a mil of variation across the diagonals. Setting up mirrors for these machines seemed a very, very tedious method. Bits of paper, pulse here, tweak there, bits of paper, pulse, run round the machine, frustration. No, I'm basically a lazy person. There's a perfectly good technology out there that's used in science labs where you can see the laser beam to set your mirrors up. I've just invented a little gizmo that'll fit onto this machine to enable me to do the same thing. And then when I thought about the process, I decided that we don't need to check at Y and we don't need to check at X. Now I'm not going to argue with you guys out there that do it. Carry on doing it. I absolutely realise that I don't need to do it. The laser beam, when it passes through the axis of the lens, will produce a focus point which is in line with that axis. And when the axis of the beam moves off centre to the lens, a distortion to the focus point occurs. And that distortion is quite significant at about plus or minus 1.75 millimetres, 6.5 millimetres away from the nozzle. Now that's a wonderful indicator of whether or not your beam is performing consistently at the 4 corners of the table. You've just got to do a nozzle burn test as I've demonstrated to you, and you can see exactly what your beam is doing. Now I'm not advocating this as the new method that you must follow. I'm just showing you, like everything else that I do, here's what I'm doing. Well, I hope you've enjoyed this little mini series. I've stumbled into it accidentally by way of trying to solve a squareness problem with my 10mm acrylic cuts. But it's been a fascinating little exploratory exercise.